Recycling agents can either be softeners or rejuvenators. And many people use the terms interchangeably, although this is not correct. A good rejuvenator in a well-designed mix will reverse the impact of aging on performance and durability. An ordinary softener is often a simple vegetable oil or a flux and may do little beyond softening the asphalt through dilution. Let's take a look at the science. The average road is approximately 95% by weight of mineral aggregates, sand, stone, and gravel, and about 5% asphalt binder or bitumen. Typically, much of the performance in the average road is dependent on the quality of the bitumen, which serves to bind the aggregates together. There are many theories and models to describe the behavior of asphalt binder at a molecular level. The phenomenon of aging can be simplified for convenient conveyance by using a colloidal model. In this method, the continuum of hydrocarbons in asphalt binder is simply split into 4 categories or fractions. Cyclics refers to the lighter aromatic or naphthenic hydrocarbons that are often associated with the degree of flexibility and flowability of the binder. The cyclics are typically the major medium of the binder in which all other fractions are solubilized or dispersed. One of these other fractions are the saturates, which are saturated hydrocarbons. This fraction is chemically inert and therefore typically sits out the oxidation process. Asphaltenes are the heaviest fraction of the bitumen and responsible for providing the necessary stiffness to resist loads. The asphaltenes are insoluble in the cyclic medium and have a tendency to associate and agglomerate if not properly stabilized. The role of asphaltene stabilization is often attributed to the resin fraction of the asphalt. This fraction constitutes intermediate hydrocarbons that are soluble in the cyclics but attracted to the asphaltenes through polar groups, preventing them from organizing into rigid structures. In unaged binder, these fractions are in a stable balance. The installed asphalt pavement is flexible and resistant to cracking and rutting. As the aging process occurs, however, the bitumen chemically changes and sees a loss of the softer and stabilizing fractions, the cyclics and resins, while seeing an increase in the stiffening fraction, the asphaltenes. As the bitumen loses these dispersants and the carrying medium's volume decreases, the asphaltenes begin to act up and agglomerate. They form stiff and brittle structures that aren't easily separated. These changes make asphalt binder less flexible and more susceptible to damage. Small flaws and micro cracks are less likely to be able to heal and instead begin to grow into larger cracks. If this aged and distressed pavement is milled into wrap and used in a new pavement, these same qualities will carry over. Here's where a good rejuvenator recycling agent, or rejuvenator, comes in. First, the rejuvenator replenishes the lighter fractions of the aged asphalt, increases the soft medium in which the asphaltene clusters reside, which is not unlike the function of basic asphalt softeners. But, unlike a softener, a true rejuvenator will also disrupt and compatibilize the asphaltene structures to restore flexibility and to improve damage resistance and healing. However, this is not the end of what is required. A true rejuvenator needs to retain these properties for the entirety of the new pavement's life. Therefore, it needs to provide equal or even better aging behavior than the original binder.